Hey everybody. In this little tutorial, I'm going to show you how to analyze the data that you exported. Now I'm just using one of your data sets, but you can do basically the same thing. Basically what we had was a bunch of data, and how it's arranged sort of depends on how you perform the experiment. So in this case, they've got the first thing they did was what's called run one, and that was the wavelength versus absorbance when you took the whole spectrum over the wavelength to find what the maximum wavelength was. Then here's their calibration, so that's what the program's calling run two. And then runs 3, 4, 5, and 6 are the runs they did with the NEOH. Okay. So I'm just going to show you how to analyze using Excel. Of course, you can use Logger Pro as well. It's maybe a little bit easier to do it in Logger Pro, but I know you don't have the software. If you do want to do it in Logger Pro, then just let me know and I'll let you borrow one of the laptops. But for now, I'll just show you how to analyze this in Excel. So the first thing that I did, I'm just calculating this for run 6. I don't know, whatever run 6 was for this particular data set. I'm going to calculate the concentration of it, because what run 6 was measuring the absorbance versus time. So once you added the crystal violet, you could see that the concentration curve curved down, right? So I'm going to calculate what the concentration is based on the absorbance. Now, how I know what the concentration was based on the absorbance was the whole idea behind doing what they're calling run 2 here, the calibration curve. So I used the straight line equation that I got from that that calibration curve to actually calculate what the concentration was. So the calculated concentration is just rearranging that that line, or that equation of the straight line. So what I've got here, again, for run 6, I'm going to take whatever the absorbance was, and I'm going to add 0.03957, because that's what the intercept was for that fitted line. And I'm going to divide by what the slope was, which in this case was 50,110. Again, for the other group, your equation was different, so you're going to have a different equation, but I'm just rearranging it for concentration. That's all. So that's the calculated concentration. I'm going to also calculate the natural logarithm of the concentration over here. So I literally just said equals ln of that number. So that's why it has equals ln of cell O2 there. And then for here, it's the same idea. It's 1 over the concentration, so it's 1 over whatever that cell value is. Just when you're inputting the cell equation, just remember to hit the equals. So equals and then whatever your equation is. So I want to repeat this for all the concentrations. So right now it's just calculating that for these, or this particular absorbance, but I want to repeat it for all of them, right? So I'm going to repeat this by clicking and dragging, highlighting all 3 of those calculations. I'm going to go to the bottom right corner where the plus sign changes to a dark black one. And I'm going to click and drag down for all of those concentrations. So I'm just clicking and dragging until I get to the bottom. And that's the end of run 6, so that's where I stop. Now I don't know if I forget which run it asked you to do. I think run 6 for this group was what you would call run 1. I think that's their first trial, but in any case, it doesn't really matter. So now I have that concentration, ln of concentration, and 1 over concentration. So the last step here is basically to figure out whether this is a 0th order or a 1st order or a 2nd order. So how I'm going to figure that out is I'm going to insert a chart, and I want it to be an XY scatter chart. Now it's going to assume a few data sets that I don't really want to, so I'm just going to delete all of these. Delete that. Delete that. Oh dear, did a lot of them. Delete that. So it's because I didn't specify a range here. It's just plotting everything. You know what? I'm just going to go select data. Let's just remove all of them. There. Now I'm going to add a data range here. And what I'm going to call this one, this is my 0th order fit. And I'm going to plot concentration versus time. So on the x-axis is going to be my time, which is this column here. So I'm going to click and drag that whole time, which I think was like 120 something seconds. Yep. Okay, so there's that. And I also want to plot the concentration. If I'm testing for 0th order, I'm going to have this be concentration versus time. So I'm going to take that calculated concentration, or those calculated concentrations, and I'm going to plot those, again, over that same time period. There we go. And I'll just hit OK. So this is my test for 0th order. I'll hit OK. I'll see what the graph looks like. Here it is. Beautiful. I'm going to test it for its linearity by basically inserting or fitting it to a straight line. So what I'm going to do is I'm going to add a chart element. Normally there'd be like a plus sign there, but I think you can just right click it and you can say add trend line, which is all we want to do. So I want to add a trend line to this. And for me, these options come up sort of automatically. I can display the equation on the chart. I'm actually not interested in the equation. I'm fitting it to a straight line, so it has to be a linear line. But I want to see how linear it is. That's the whole point of this. So all I really care about is the r squared value. So I click on display r squared value on the chart, and it tells me basically how good the linear fit was. So in this case, it's 0.8956. And that's how straight the line is. Now, it obviously doesn't look like a straight line, but if it were a 0th order reaction and I plotted concentration versus time, it should look like a straight line. This one doesn't look like a straight line, so it's not 0th order reaction. So I would just repeat that for 1st order and 2nd order. So I'd make another plot, time versus ln concentration for my 1st order test, and see how straight that line is, again, just by plotting it and seeing what the r squared value is. And then doing the same thing for 2nd order, which would be time versus 1 over concentration, right? If it is a 2nd order reaction, then plotting 1 over concentration versus time should give me a straight line, right? And I'm going to test how straight that line is with the r squared value. So basically, whichever one of these plots has the r squared value that's closest to 1 wins. And that's what I'm going to call the reaction order. Whichever one looks like the straightest line, that's the reaction order. All right, and that's sort of it. So once you've done that, then you'll be able to tell whether it's a 0th, 1st, or 2nd order. It doesn't look like it's a 0th order, so it looks like it's either 1st or 2nd. But once you have that established, then you can continue on with the rest of the analysis. And I think the rest of the analysis is pretty straightforward. I think this part is the real difficult part. After that, I think you're just trying to indicate whether, or like calculate the rate constant. Basically the same thing you did on your assignment. Okay, so that's how to do this in Excel. Again, if you want to do this using Logger Pro, just let me know and I'll let you borrow a laptop. You're going to do basically the same thing, but I think it just does it a little faster. And you're using your original data set. So that's it for that. Go ahead and analyze the rest of the data. And if you run into troubles afterwards, just let me know.